Good afternoon everyone. Last class we are discussed about gamma distribution movement generating function complete assessment. And today we are going to discuss about the characteristic function of gamma distribution. Characteristic function of gamma distribution is given by the probability density function of gamma distribution. Probability density function of gamma distribution is given by f of x is equal to x power n minus 1 into e power minus x by gamma n, and 0 less than or equal to x less than or equal to infinity, n greater than or equal to 0. So capital N is the parameter, and characteristic function of gamma distribution is given by pi x of t. Pi x of t is equal to expectation of e power I dx, like expectation of x is equal to integration x into f of x dx గా రాస్తారు. So here x plus లో e power I dx ఉంది కాబట్టి we can write pi x of t is equal to integration e power I dx into f of x dx. So here pi x of t is equal to integration 0 to infinity e power I dx into f of x అని అంటే x power n minus 1 into e power minus x by gamma n dx. So gamma n is the constant term we can write out of the integration. Here gamma n integration 0 to infinity e power I dx into x power n minus 1 into e power minus x, and here e base equal గా ఉన్నాయి. Here e power I dx and e power minus x base ఈక్వల్ గా ఉన్నాయి కాబట్టి పవర్ యాడ్ అవుతాయి. gamma n into 0 to infinity x power n minus 1 into x power n minus 1 into e power minus 1 minus id 1 minus id into x and dx, and this is the formula of integration 0 to infinity x power n minus 1 into e power minus ax dx is equal to gamma n and a power n. This is the formula. We can substitute gamma n into a power n, a power n గా కన్సిడర్ చేసుకుంటాం. అండ్ here you can write simply instead of this term ఈ టర్మ్ ప్లేస్ లో you can write gamma n into so 1 by gamma n here also 1 by gamma n into gamma n by 1 minus it power n. This term and this term get cancelled. Finally we can write minus it whole power minus n is a pi x of t. This is the characteristic function of gamma distribution. Then we want to find out the moments consider mu1 dash is equal to you can write minus I d by dt of pi x of t and t equal to 0. So mu1 dash is equal to minus I into d by dt and pi x of t is the characteristic function of gamma distribution. You can write here 1 minus it whole power minus n and t equal to 0. And derivation of the 1 minus it whole power minus n is equal to mu I dash is equal to minus I and minus n into 1 minus it whole power minus n minus 1 and again the derivation of minus I and t equal to 0 and minus get cancelled. Finally I into n into 1 minus it whole power n minus 1 and minus I and t equal to 0. ఇక్కడ మైనస్ I ఉంది, ఇక్కడ ప్లస్ I ఉంది. మైనస్ I స్క్వేర్ ఇంటూ n into 1 minus it whole power n minus 1 to t equal to 0. Then substitute t equal to 0. Minus I అంటున్నాం కాబట్టి I into I square is equal to minus 1 and minus 1 and minus 1 and 1 minus it equal to 0 substitute చేస్తే minus n minus 1. That should be 1 into n into 1 and n. The mu1 dash is equal to n in gamma distribution. mu1 dash is equal to similarly we can find out the mu2 dash, and here we will get the mu1 dash is equal to n and mu2 dash is equal to n into n plus 1, and variance mu2 is equal to mu2 dash minus mu1 dash whole square, and mu2 dash అని అంటే n into n plus 1 minus n square, and n square plus n into n square get cancelled. Finally n is the variance. So variance also will get the small n, and mean equal to variance in gamma distribution. And cumulative generating function of gamma distribution is given by the PDF of gamma distribution, the probability density function of gamma distribution is given by f of x is equal to x power n minus 1 into e power minus x by gamma n 0 less than or equal to x, less than or equal to infinity, n greater than or equal to 0. So n is the parameter, and cumulative generating function of gamma distribution is given by kx of t is equal to log of mx of t. This is the formula of cumulative generating function. So kx of t is equal to log of mx of t is nothing but 1 minus t whole power minus n. So log ఉంటున్నాం కాబట్టి minus n of log 1 minus t, minus n log 1 minus t is the kx of t, cumulative generating function. Here we want to find out the central moments. Consider mu1 dash is equal to k1 is equal to mu1 dash, k1 is equal to mu1 dash is equal to d by dt of kx of t, and t equal to 0. d by dt of kx of t is nothing but minus n into log minus n into log 1 minus t, and t equal to 0, and minus n is the constant term out of the derivation, minus n, and d by dt of log 1 minus t and t equal to 0 minus n into 1 by 1 minus t into 1 ఎందుకంటే t యొక్క డెరివేషన్ ఏమవుతుందంటే -1 జనరేట్ అవుతుంది and t equal to 0 minus minus get cancel you get the n 1 minus t and t equal to 0 then we substitute t equal to 0 1 by 1 minus 1 t equal to 0 substitute చేస్తున్నాం కాబట్టి n జనరేట్ అవుతుంది that is the k1 is equal to mu1 dash is equal to the mean then we want to find out the k2 consider k2 is equal to mu2 d square by dt square kx of t and t equal to 0 then we want to find out the first derivation of n by minus 1 minus t 1 minus t and t equal to 0 n is the constant out of the we can write like this n into d by dt of 1 minus t minus 1 and t equal to 0 can write and derivation of the term minus 1 into 1 minus t and minus 2 then the derivation of t minus t is equal to 1 and t equal to 0 minus get cancelled and n into 1 minus t whole minus 2 and t equal to 0 substitute t equal to 0 n into 1 minus 0 whole square finally n this is a k2 and mu2 and also variance n is the mu2 and k2 value and also consider k3 that means dq by dt cube kx of t and t equal to 0 d by dt of second derivation is n into 1 minus t minus 2 and equal to 0 so here n is the constant d by dt of 1 minus t minus 2 and t equal to 0 and derivation n into minus 2 and 1 minus t minus 3 into minus 1 and t equal to 0 minus get cancelled 2n and 1 minus t minus 2 and t equal to 0 We'll get the answer is t equal to 0 substitute చేస్తే 2n minus 0 whole power minus 3. Finally 2n is the answer, is a k3 and mu 3. Consider k4 is not equal to mu 4. D power 4 and dt power 4 kx of t and t equal to 0. d by dt of 2n of 1 minus t whole power minus 3 and t equal to 0. 2n is out of the derivation, d by dt of 1 minus t minus 3 and t equal to 0. 2n of minus 3 into 1 minus 3 and here minus 4 and minus 1 and t equal to 0. Minus 1 and minus 1 get cancelled, minus get cancelled, and here 6n of 1 minus 3 whole power minus 4 and t equal to 0. Then substitute t equal to 0. 6n minus 0 whole power minus 4. You can write 6n is equal to k4. Then we want to find out the mu 4. Mu 4 is equal to k4 plus 3 into k2 square. This is the mu 4 formula. This is 6n plus 3 into n into square. 6n plus 3 into n square. And mu 4 value is equal to 6n plus 3 into n square is the mu 4 value. And also we want to find out the skewness. Skewness beta 1 is equal to mu 3 square and mu 2 cube. Mu 3 square by mu 2 cube. We can write mu 3. The value is 2n square and mu 2 is n cube. Finally, we can write 4n square and n cube. N square and n cube, and here 4 by n. 4 by n is a beta 1, the skewness. Courtesy is a beta 2. Beta 2 is equal to mu 4 by mu 2 square. Mu 4 by mu 2 square is equal to 6n plus 3n square. 3n square and n square is equal to, we can write 6n by n square plus 3 into n square by n square and 6 by n plus 3. 6 by n plus 3, and here as n tends to infinity 1 by n tends to 0. Then the PDF curve of gamma distribution is symmetric and mesocurtic curve. and this is all about gamma distribution C.G.F, cumulating generating function in today's class. And tomorrow we are going to discuss additive property and mode of gamma distribution and properties of gamma distribution. Okay, thank you.